First I am going to teach about the direction of refracted ray. We need to draw long straight line that is nothing but principal axis of lens. So now middle we have to take one small point, from that 3 centimeter distance left side one more point, still 3 centimeter left side one more point. Likewise right side also 3 centimeter gap, 2 more points we have to mention, total 5 points we have to mention. So middle point is nothing but the optic center. So right side and left side, first point we have to use F, next one is 2F, that is nothing but twice the focal length. Middle of the lens we need to draw a dot line. First ray I am going to explain, that is nothing but parallel ray which is passing parallel to the principal axis. Up to the dot lines this ray want to come straight. If the ray is parallel, after refraction it should pass through principal focus. So this is refracted ray direction. If the ray is parallel to principal axis, after refraction it should pass through principal focus. So second ray which is passing through optic center. If the ray which is passing through optic center without deviation, it will pass straight line. So second ray is passing through optic center, without deviation it is traveling straight line. So angle between incident ray or angle of deviation when the light ray is traveling through optic center is 0. Third ray which is passing through first principal focus. Which is passing through first principal focus, after refraction it want to pass straight line. First ray parallel ray which is passing parallel to the principal axis, after refraction it want to pass through principal focus. Next ray is passing through optic center, without deviation it will travel straight line. Third ray which is passing through first principal focus, after refraction it should pass parallel to the principal axis. All the refracted rays are meeting at one point. This is the position of image. Object we should mention AB, image we need to mention A dash, B dash. In these three, any two rays we can use to draw the image formation by convex lens. Before that I am going to explain about the principal focus of convex lens and concave. So now I am going to explain about the principal focus of convex lens and concave lens. Parallel rays falls on convex lens. After refraction, the refracted rays are going to meet at one point. So this point is called principal focus of convex lens. Likewise, the parallel rays fall on concave lens. All the light rays are get diverged. So the diverging light rays are making to meet backwards. All the diverging light rays are starting from one point. It is appearing to diverge from one point. So this point is called the principal focus of concave lens. Principal focus of convex lens is always real. Why? Because we will get the image. As I said, one small experiment, we are going to focus the sunlight on the paper, we are going to get a bright spot. So that we are going to catch on paper, that is called a real image. So principal focus of convex is real, principal focus of concave is virtual. Next one is nothing but focal length. What is meant by focal length? Means it is nothing but the distance between the optic center to the principal focus is called focal length. Focal length is represented by the symbol small f. Likewise concave lens also, the distance between principal focus to the optic center is called focal length of concave lens. So now again I am going to teach about the image formation by convex and concave lens. First I am going to explain how to draw the image formation by convex lens. A long straight line we need to draw. We need to mention a small dot points at the middle of the straight line. So that middle point you have to mention like O. That is nothing but optic center. Next, from that point to leftwards 2 more points, we have to mention 3 centimeter gap or equal distances like 3 centimeter, 4, 5 or minimum 2 centimeter even you can take between 2 points. So here I took little more. So O to this point 3 centimeter and this point to this point also 3 centimeter gap we need to mention. Like that 2 more points, that even 3 centimeter gap from optic center we need to mention. So this first point from optic center we are going to mention principal focus. Next point 2f, double the focal length. Now you need to take a compass and you need to place a needle point at 2f and you extend the pencil point a little bit more than O and you need to draw an arc. Like that same measurement you need to keep the compass needle at this 2f and again you need to draw an arc in this side. So you are going to get convex. So we need to draw convex lens. Now we should keep object beyond 2f. This is 2f. Beyond 2f we need to keep an object. Object with arrow mark we should mention. This is nothing but A, B. 2 rays I said enough to find the position of the image. After refraction it should pass through principal focus. Next ray want to pass through optic center without deviation, it is going to travel straight line. Where the 2 refracted rays are going to meet, that point image is going to form. So image is, if object kept beyond 2f, image is going to form between f and 2f. Size of the, compared to the size of the object, size of the image is very less. Next I am going. Again I used parallel ray and the ray of light passing through optic center. The refracted rays also going to meet at 2f. If object kept at 2f, image also going to form at 2f. In this case magnification of lens is 1. Image distance is equal to object distance. Next, object kept between f and 2f. This is object AB kept between f and 2f. The ray which is parallel to the principal axis after refraction passing through the principal focus. Next ray which is passing through optic center without deviation, it is traveling straight line. Where does the 2 refracted rays met, that place image will form. In this case we know the size of the image, size of the object and size of the image. Size of the image is larger than size of the object. So the image is inverted, real and enlarged image forms beyond 2f. First case object kept beyond 2f, image formed between f and 2f but real, inverted and diminished image. Second case object kept at 2f, image also formed at 2f, then real, inverted and same size image formed at 2f. Now object kept between f and 2f means image formed beyond 2f, that image is real, inverted and enlarged image. Next case object kept at principal focus f. So here the refracted rays are going to get parallel. If the refracted ray are parallel, the image is going to form at infinity. In this case also the image will be real, inverted and enlarged image forms at infinity. Next case object kept between f and optic center. So a small image we will keep between f and optic center. The refracted ray are going to be diverged. Parallel ray passing through principal focus and the ray which is passing through the optic center, both the refracted rays are going to get diverged. So this diverged rays backward we are going to meet with the help of dotted lines. There we are going to get in virtual image. Erect straight image we are going to get. So erect, enlarged, virtual image formed in the same side of the object. So image formed by convex lens is real and virtual. If virtual image when we are going to get means the object placed between principal focus and optic center. So in our house we will use magnifying lens to read the paper. Elderly people, they will use to read the newspaper with the help of magnifying lens. How they will hold the lens means very near to the paper. If they are holding means they are going to see the big size of the letters. Why they are holding very near means the letters will be the object. The object want to place very near to the lens means the object will placed between the focal length. So if object placed between the focal length, enlarged image will form. That reason only we want to hold the lens very near to the paper. If we will take little far, we won't see that much larger object. So image formed by convex lens is always real and virtual. One case only we are going to get virtual object, in when means the object placed between the focal length. So this reason only we are calling convex lens, one more name is magnifying lens. Image formed by concave lens is always virtual. Where you are keeping the object even, always the image are going to get between the optic center and principal focus. Very diminished image and erect image, virtual image formed by concave lens. Only with the help of a single diagram I am going to explain about the image formed by concave lens. So how to draw I am going to explain now. We want to draw a long line. At center point we need to keep a point. From these two same 3 centimeter gap, total 4 points we have to mention. So center point we need to mention optic center, same as like convex lens, F, 2F, here also F, 2F we need to mention. So how to draw convex lens, as I explained earlier, like that concave lens, what we need to do means, again we need to take a compass, the needle point placed at 2F, the pencil you have to extend little before O, and here you need to draw one arc. With the same measurement again you keep at this 2F, and this direction again you need to draw an arc. So this 2 arc we will join means we are going to get concave lens. So this method we need to draw the lens, concave lens. First, wherever you can keep the object at 2F or beyond 2F or between F and 2F, wherever you are keeping object, image will form between F and optic center. With one example I am going to explain. First, I am keeping the object beyond 2F. AB I kept beyond 2F. Same first ray is parallel. This we know diverging lens. So it will start to diverge from principal focus. This direction you are going to get straight line diverging. Next ray which is passing through optic center, without deviation it is going to travel straight. Where these two rays are going to meet, their image is going to form. So between F and optic center image is going to form. We know compared to the size of the object, size of the image is very small, but straight image we are going to get. So the image formed by concave lens is always virtual, erect and diminished image always formed between optic center and principal focus. So linear magnification of lens, same like mirror, it is defined as the ratio of height of the image to the height of the object. Linear magnification of mirror, when it is equal to when means object placed at 2F, only is applicable for convex lens. So magnification of lens is nothing but the ratio of height of the image to the height of the object. One more formula, image distance divided by object distance. For mirror magnification we will use minus, but the lens we will use plus V divided by plus U.
ನಾವು ಮಾಡ್ತಾ ಇರೋ ವಿಡಿಯೋಗಳು ನಿಮ್ಗೆ ಇಷ್ಟ ಆಗಿದ್ದಲ್ಲಿ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಪಕ್ಕದಲ್ಲಿರೋ ಬೆಲ್ ಐಕಾನ್ ಅನ್ನ ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ ನಾವು ಮಾಡೋ ವಿಡಿಯೋಗಳ ನೋಟಿಫಿಕೇಶನ್ ನಿಮಗೆ ಮೊದಲು ಬರ್ತದೆ. ಯಾವುದೇ ರೀತಿ ಸಂದೇಹಗಳಿದ್ರೆ ಕಮೆಂಟ್ ಸೆಕ್ಷನ್ ಅಲ್ಲಿ ತಿಳಿಸಿ. ಹಾಗೆ ಈ ತರಗತಿಗಳು ಹೆಚ್ಚಿನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಲುಪುವಂತೆ ಶೇರ್ ಮಾಡಿ.